Hello, hello. Thank you for joining us for this session of AWS On Air. My name is Eddie Zaneski, and I serve as a developer advocate here at Amazon Web Services. I'm joined today by two awesome folks. Anoop Kapoor, why don't you introduce yourself?
Hi, my name is Anoop. I'm a product manager on the Amazon ECS service. I work on a few different areas within ECS, but the one that I'm most excited about is the one that I've been working on for the last few to several months, which is the product that we'll be talking about in the session.
Awesome. We're also joined by Massimo Refore. I've practiced my French R there.
Thank you. You pronounce that much better than I would do. Hi, folks. My name is Massimo. I'm a principal technologist in the AWS container team. Differently from Anoop, I work across all of our services. So I span ECS, Fargate, EKS, ECR, AppMesh, and more, Proton also. But I've been working with Anu very closely on the launch of this new capability that we're talking about.
Very cool. And so Anoop, why don't you start by telling us what we're actually talking about? What is ECS Anywhere?
Yeah, so just to begin with, what ECS is. So ECS is a fully managed container orchestration service. The way it works is that the control plane is fully managed. It's in the cloud. You don't get to see that. Everything is taken care of for you. And then you've got the data plane, and for that you've got the options of, and that's where you basically run your containers on. So you've got the option of running them on EC2 instances where you want full control over the instances and you want access to the underlying host. So that's what you can run them on. And then the second option that we've given is Fargate, which is a fully managed serverless experience, in which case you don't have to worry about any instances. You basically just say, I want to run my containers, and everything on the data plane is taken care of for you. What now we're doing is we're saying that with ECS Anywhere, you can bring in your own compute capacity to an ECS cluster. So if you have a laptop, you have an on-prem bare metal server, you have a VM, uh, as long as you can install the ECS agent on it, you can connect that back with the ECS cluster. And when the time comes to run your containers, today you've got the option of you can run them on either Fargate or EC2. Now you'll get this third option, and you just end up selecting that option, and that's where your containers are going to end up running.
Very cool. And I forgot to mention, we're actually watching Twitter. If you tweet at AWS on air, we will be able to answer your questions. Hopefully, at the end, we'll have some time left. So, Massimo, why don't you tell us what customer problems we're actually solving with this?
Yeah, sure. So as Anup was alluding to, what we have done over the years is to relax a little bit the option that customers have to run ECS workloads. So as Anup mentioned, we started with EC2, we added Fargate. We also added other options, particularly last year with Outpost, which is managed infrastructure AWS managed infrastructure that can be located inside the customer data center. However, customers were asking us even more flexibility because of some other use cases. I'll just name a couple of them, like capacity that they already have and that they have to use instead of having to buy new capacity or before moving to the cloud was an obstacle for them because now they have this amount of capacity that they would like to use in a cloud native way, so to speak, that they cannot because it's not managed by AWS. And the second use case is some of these customers operate in very regulated industries or countries, and they have to manage their own infrastructure. So they could buy or they could rent an AWS Outpost technically, but some of these compliance requirements require them to manage the infrastructure. So they were asking us, is there a way to leverage the simplicity of ECS, so the fact that you don't have to manage this orchestration layer, so leaving the ECS control plane into the cloud, but allowing us to consume that capacity that we have on-prem, either because we already have it and we need to consume it, or because for compliance reasons, for example.
Awesome. Why don't we just jump right into the demo? I'm sure folks want to see that, and
Sure.
then we can talk about some of the other stuff afterwards.
Sure, absolutely. So I prepared this short video. But before I show you the video, I just wanted to build a little bit of context around this demo. So what this demo does is this thing. So you can deploy this application in a task on the AWS cloud. This is a small Python application that basically manages and act upon files that exist on an Amazon EFS share in a source folder and in a destination folder. And it also reads from an SQS queue. So basically, the idea here is that the application monitor the SQS queue, and if there is a match in the file name that exists in the source folder, it will take that file, it will rename it, and it will move it into this other folder, the destination folder. And it will also log into CloudWatch, right? So this is a very simple example of how you can use multiple cloud services to do batch workloads, for example, or anything. So what we're going to show in this demo is this. So we want to use the very same application in the very same ECS native task, but instead of running on Fargate in the region, we want that task to run on customer managed infrastructure on-prem. Obviously, there is no EFS on-prem, so we're going to use a file share on-prem to do this. But other than that, the application is going to read from the SQS queue, is going to push logs into CloudWatch, and do everything that this application, ECS Cloud Native application does. So that's kind of the context. Let's jump into the actual demo. So what you see at the very top is the console that I'm going to use to launch some of the commands that will allow us to prepare the infrastructure on-prem, which is represented by those two boxes, those two red boxes at the bottom. Imagine that there are two SSH sessions into two things that are running on-prem. Think about VM or bare metal, whatever. We'll talk more about this. So what I'm doing right now is I'm preparing the environment. I do have a script that does this for us. This is not how we're going to deliver this experience. This is just a script that I built just to make it more demo friendly, so to speak. So the first thing that I'm doing is I'm setting a few variables, because to use this technology, I need to point to a development environment and not to the production environment, because this feature is not yet in production. So momentarily, you will see me setting these environment variables in the console that you see here. That's what I've done right now. The second thing that I'm going to do in this main script, so to speak, is creating the ECS cluster. So remember, Anoop said that you can create an ECS cluster in the region, so that remains in the region, the definition of the ECS cluster. The cluster is called external. Remember this name. The cluster name is external. It's a fantasy name. I could have called it, whatever. I just picked external as the customer name. Now we're getting into preparing the on-prem infrastructure. Before we do this, we need to generate SSM keys, because SSM, or Systems Manager, is the service that we're using to basically register those two on-prem instances into the AWS cloud, right? So this script is going to stop now and telling me, now copy this activation ID and activation code into these SSH sessions that you see at the bottom. And now we're going to install the SSM agent. The SSM agent is the first prerequisite to be able to use that capacity as ECS capacity. So I'm doing that right now in the first instance, in the first on-prem instance. To do that, I have another script called SSM agent script. Pretty telling. It just install the Ubuntu snap because I'm using Ubuntu on these two instances here. So right now it's downloading the SSM agent. It's installing the SSM agent. And the other thing that it does, it registers that agent into AWS Systems Manager so that that instance becomes a Systems Manager managed instance. That allows us to create a secure channel to talk back to the cloud and for the cloud to talk to this EC2 or to this managed instance. I cut the video for the second one because it's exactly the same. So I'm going back to my main script. And what it does, the main script, what it does at this point, it queries Systems Manager and it asks System Manager to give us a list of managed instances. As you can see, now we have two managed instances. If you look at the bottom of this JSON, it says instance A and instance B. They are exactly the host names of these two instances at the bottom of the screen, the red sessions that you see at the bottom of the screen. The other thing that we're going to do, and we're doing this leveraging the Systems Manager capabilities like distributor, we're going to install the ECS agent on these two instances. This is the step when they become capacity that connects back to the cluster. Because the ECS agent is basically a container, well, what I'm doing now is I'm watching a Docker PS on these two instances because I want to see when these containers come up. And that's what I'm doing. In the main script, I just launched and I told Systems Manager, go and install the ECS agent on these two instances. This takes a few minutes, so I'm cutting the video again here, and I'm coming back when the agent is running. As I said, it usually takes a few minutes. So as you can see, the agent is running now on these two instances. That means that these two instances have been registered in the cluster that I've created. As a matter of fact, the main script queries that cluster and it asks, show me the instances that you have, and it says 2. I see the same thing in the console. This is a development version of the console. So I do have an external cluster here, which is what I created before with the main script. As you can see, I have 2 container instances. Those 2 container instances are the 2 instances that I've just registered through those 2 scripts, as well as the install of the ECS agent that I showed. So what I have now is my infrastructure ready to set up my application. My application is already running in the cloud, so I'm leveraging the very same container image that I'm using in the cloud. I'm leveraging the very same EM roles that I'm using in the cloud because this is an ECS task that we're deploying. So I'm going to create a new task. The first thing that you see in this console is that there is now an external launch type that we have added to Fargate and EC2. Historically, you can only have launch type of type EC2 or Fargate. Now we have created this new external launch type. So instead of filling out all of these in the UI, I'm just copy and pasting the JSON that defines my task, the task definition. So this is what I'm doing now. As you can see here, I have, well, you probably don't see it in this very short demo, but I'm using the very same roles. I'm using the very same container instance. I'm using the very same configuration that I use when I deploy this task in the cloud. That's the task role that you see underneath the task definition name, and that's the task role that I'm using in the cloud. That contains the policy, EM policy, to connect to the SQS queue and being able to read from that SQS queue. As you can see, the compatibility requirement is now external, and that's the container that I'm running. That container is exactly the same container that I'm running in the cloud. Now let's run this container or actually this task. So I'm going action and run task. Again, I see another option when I launch this task, external. This is the new option that we're adding. I want to launch this task on the cluster called external. I'm sorry, I should have picked a different name for the cluster in retrospect because I'm calling everything external here. The cluster external name is a fantasy name again. And now I'm running the task. I'm saying just run this task. So what happens here is that the control plane says, okay, someone asked me to run this task in mode external with launch type external. So I'm going to launch these on either one of those two EC2 instances in the cluster that are external to the cloud, so to speak. So if I go back, remember I still have that Docker watch Docker PS running. I see that I have a new task, or actually a new container, which is my application now running on one of these, actually on instance A, because the orchestrator picked instance A to run that task. It could have picked instance B. It doesn't matter. So now that I have my application running here, what I'm going to demonstrate here is actually running my application. So remember, my application watch the SQS queue for messages and try to match the body of that message with a file name in the source folder. So I'm mimicking him here, two file share, source folder and destination folder. They are mounted on these two instances. So everything that I'm doing on one instance is reflected on the other. So the destination folder has already some files in it because I was processing other files already. What I'm doing on the left-hand side is I'm going to watch the destination folder on these instance. I'm sorry, the source folder I'm watching. What I'm going to do on instance B, the instance on the right-hand side, is I'm going to create a bunch of files on the source folder because I want to then act on these files based on the messages that are coming in the queue. So I'm going to touch a number of files, 001, 002, 003, 004, and 005. There was a little mistake that I did when I recorded this because I created this file in the wrong folder. I created this in the root folder, data folder, whereas I need to create them in the source folder. Okay, so I'm deleting them here. Sorry about the glitch, and I'm recreating this file in the source folder. As I create them on the right-hand side, you will see those popping up on the left-hand side because they are mount folders, right? They are mounted on both instances. Now that I have done this, what I'm doing is I'm watching the destination folder on the right-hand side. So on the left-hand side, I'm watching the source folder. On the right-hand side, I'm watching the destination folder. Okay, so as you can see in the source folder, I have 5 files that I could act upon when I see messages coming into the queue. So the next step is I'm going to put messages into the queue. I'm going to put message 001, 002, 003, 004, 005. What the application is doing now is it's reading from this queue, it's comparing the file name with the body of the message that I'm putting into the queue. And if there is a match, it's going to take that file, rename it, and move it into the destination folder, which is what it's already doing. As you can, there is a little bit of an artificial delay that I put into the application. Otherwise, it would just move everything all together. But as you can see, it's moving 001, 002, 003, 004, and 005 eventually into the destination folder. So I'm using the very same application logic, the very same container image, the very same EM roles, the very same everything running on-prem, acting on data that are on-prem. The last thing that I wanted to show you in this demo is that if I go to CloudWatch and I go into the stream that identifies that task running on-prem, I see that that task is logging into CloudWatch. As you can see, I'm logging. Other than moving and actually acting on the data, I'm also logging what I'm doing in the data. And as you can see here, hopefully you can see it, I'm logging that I read message 001 and I'm acting on 5001. So that's kind of the flexibility that allows you to give you. You are essentially being able to move cloud native workloads on your on-prem infrastructure.
That's awesome, and there's definitely a lot to unpack there. Quick question though, I'm sure that these agents are running on some beefy metal server somewhere, right?
That's interesting because actually, where these two instances were running were on two Raspberry Pis. They were running on two Raspberry Pis. Actually, I had to cheat when I said that I was using the very same container image because I had to recompile that image, to rebuild that image on a G class Graviton2 EC2 instance to create an ARM version of that container image, because that's what I'm using in here. So I was a little bit cheating, but for a good reason. The other thing is that these Raspberry Pis even run on a wireless network. They're not even connected to the Ethernet. So everything that you saw in that demo, I have actually been delivering it on two Raspberry Pis connected over wireless.
That's awesome. So Anoop, when we say ECS Anywhere, I guess we actually mean ECS Anywhere?
Yeah, pretty much. As long as, whether it's, we don't care about like whether it's a VM, it's like in this case it was Raspberry Pi, or it's a bare metal server. As long as you can install the ECS agent and you can install the SSM agent, that's all that's required, and you can connect that back with the ECS cluster, and it's available as data plane for you to run your containers on.
Very cool. And so how has our data plane evolved over time to get here?
So I think it's a very interesting question. And the reason why I say that is because we started with EC2. ECS was launched in 2015, and the data plane that was available at that time was that you can bring in your EC2 instances, and that's where you run your containers on. Then we progressed. We said, okay, we heard from customers that they don't want to be managing these EC2 instances. All they want to do is run containers. So we came up with Fargate, a fully serverless option for running your containers on. Then we progressed. Customers, they wanted these EC2 instances to be, or the compute to be closer to where they were going to be processing their data. So we came out with AWS Wavelength. We came out with AWS Wavelength for 5G, and then we came out with AWS local zones for low latency workloads. For example, we've got the local zone in the LA region, and that's being used by a lot of media and entertainment customers. Then we also extended to where customers said that, yes, we want the same capability of AWS, we want the same APIs, but we want that track to be sitting in our data center. So we came out with Outposts. And the really nice thing is that as these options became available, these options continued to surface as data plane options for ECS. So that's how the evolution took place, and we went all the way from just EC2 instances running in region to Fargate to Wavelength to local zones to Outpost, and now we're saying that you can literally bring in your own compute capacity, and you can attach that to an ECS cluster.
Cool. That's awesome. That's quite a journey. As far as timeline goes, I'm sure people are itching to get their hands on this. What are we looking at for a timeline here?
So right now we are targeting, we'd love to get this in the hands of our customers as soon as we can. Right now we are targeting the summer of 2021, but we do have a request info form on the Amazon ECS webpage. And if you leave your contact information there, we'll keep you apprised of as we progress with the development. As we have more information, we'll be able to share with you.
Very cool. And Massimo, what have you been hearing from folks about how they can use this? What about use cases?
As I said before, I mean, the use cases are very very broad, right? And I think that the value that these folks see is the fact that the management burden for this is very low, because remember that the control plane remains in the cloud. So lots of the complexity that comes with containerized workload is to how you manage the orchestration of these workloads. And the good thing that that they like, and it's a progression of the fact that they like the simplicity of ECS. They like this because they can maintain the management burden of these very low. The only thing that they need to do is to install the ECS agent, and they enable that capacity to support cloud native workloads with very little burden. In terms of application use case, I would like to say that we're going to be interested in hearing how customers are going to use this, because as always happens, when we launch something, thinking that it fits a particular use case, customers come back with a lot of other interesting use case. So batch workloads come to mind, like what I was showing here, but it could be literally everything.
Very cool. So you mentioned we have the request info form on the website. How else should customers reach out and let us know the things they want to see in this?
I think that request info form is the best thing that we have at this time. And then as we get more places where we can have customers reach out to us, we'll be able to inform.
Cool. Yeah, so you heard that here. So hit that request info form. We'd love to hear what you're thinking, what you want to see out of this. And I guess that leads us to probably our last question. What does the roadmap look like? What are we planning to do? What kind of features?
Yeah, I think it's going to come down to what we are going to like. That's where, to Massimo's point, we are super excited to look forward to what we hear from customers and what kinds of use cases. So one of the things that we really want to look into is what is the networking aspect going to look like in terms of service discovery, in terms of service mesh. What is that experience going to look like? The possibility we've already heard from some customers that they want to run the workloads and they're on their on-prem capacity, but as their on-prem capacity comes to being fully amortized or close to retirement, instead of adding more on-prem capacity, they want to move that workload to the cloud. So how do we enable this super easy one-click migration from your on-prem capacity to Fargate or EC2? So these are some of the areas that we are going to be looking at. But at the same time, we are really looking forward to hearing from customers what their use cases are, what they would like to see. And based on that, we can iterate as we go through the development process over the next few months.
Awesome. And with that, we're up on time. Thank you both for joining me and showing me the awesome stuff that you've been working on. I'm sure our customers are very excited. Go find that contact form. We'll be keeping an eye on Twitter, so be sure to tweet any questions you have to @AWS_on_air. And I hope you enjoy the rest of reInvent.
Thank you.
Thanks, Eddie.
Bye.